Hey guys, this is Craig Migliaccio with acservicetech, and today what we're going over is measuring the static pressure of a running air handler system in order to determine our airflow. So we use our static pressure measurements and we can input them onto the manufacturer's literature in order to determine what the airflow is for that blower motor setting. So whether you're on low, medium, or high, you can look up here in the manufacturer's data and compare that with your total external static pressure, which is a measurement of both the return static pressure and also the supply static pressure. So what static pressure is, it's the amount of pressure that the blower motor needs to exert in order to move the air through an object, and this object is ductwork. So we use our static pressure tip, which is right here. We drill a 3/8 inch hole in the return duct and the supply duct. We insert this tip in, and this tip right here should be pointed with the airflow coming towards it. You have your holes right here on the side. So our static pressure tip's connected to a water column manometer. So we're measuring our inches of water column. And you can do that with a clear tube with your inch marks, because we're measuring inches of water column. But I typically just use my dual digital water column manometer in order to take my measurements, because I use this for testing pressure switches and setting gas pressure and things like that. We also use static pressure measurements across components in order to see if there's a ductwork obstruction, something blocking the airflow. So if there's a large pressure change across a component, and that's when we know that there's an issue with it and that there might be a blockage. So I'm going to go ahead and take my measurement first down at the return, and then I'm going to take my measurement up at the supply. The air handler is running right now, and we have our static pressure tip installed in a 3/8 inch hole in the duct. And when we're done with that, we're just going to put a duct plug right in there. But you want to have your hole drilled right below where your filter rack is. In this case, this air handler did not come shipped with a filter in it, so we wouldn't have a filter in here while we're taking our measurements, because the manufacturer's literature says that it's not included in the external static pressure measurements. However, we have a filter in the filter return air grill at the inlet of the return. If you did have a filter that was shipped with the air handler, you want to have that in here when you're taking your total external static pressure measurements, because that's typically included. In this case, the air handler was not shipped with a filter, so it's not included. Anyway, we have our red arrow pointing in the direction in which our tip is facing at. So we want to have it faced towards where the airflow is coming in at. And you see we have a measurement of 0.16 inch water column. And I just wanted to show you this one other thing. You're typically going to have mastic covering over your drives where your slide are, but I pulled this apart just to show you. I'm going to put this tip in on an angle. You're going to see that you have a lower static pressure over here, and the further you get away from the air handler, the lower your static pressure is going to be. So 0.14. So I just wanted to discuss that with you. So that's why you want to get as close as possible. You don't want to be in this duct over here. You want to be right here. Now we have our static pressure tip right here in the supply, and you see it's pointed downwards. We have it on the side here because the air handler supply is not so wide. It's only back here. So we wouldn't want to have our tip over here because it wouldn't be in the main airstream. So you see that we're reading right about 0.16. It's going to be pretty turbulent there, but we're trying to get as close as possible. So we're at about 0.14 to 0.17, 0.18. So I would say let's go with about 0.16. So that's our static pressure for our supply. So this is where you want to take your measurement at, right where the air is exiting the air handler and entering into the supply plenum. You would not want to have it over here, because this static pressure measurement is going to be likely lower. So we're reading anywhere from 0.12 to 0.14, so that's a lot lower than in this plenum here. And that's because this is not a transition. This is just a straight box plenum, and so the pressure is going to be a lot higher in here, and the air is turbulent stuff trying to make it into this duct. By the time it gets into this duct, it's going to be a lower pressure. Here's our airflow data, and we have a B for our model number. And we were running the airflow across a dry coil because we turned the outdoor condensing unit disconnect to the off position, so the compressor was not running. However, the blower motor was running. And I checked to see what tap we were on. Even though we're in cooling mode, the blower tap that was being used was low. But here you have low, medium, or high, and we happen to be using low. And here we have our total external static pressures up here. and we're going to be lining up on 0.3. So 0.3 and low right here is where we're going to end up at. But the reason we ended up at 0.30 is because we are adding our static pressure on a return with our static pressure on the supply. However, our return static pressure was negative and our supply static pressure was positive. So we got 0.16 at the supply and negative 0.16 at the return. So technically the equation would be positive 0.16 minus a negative 0.16. But anyway, you just add them together. And so we get 0.32 for our total external static pressure. So we're very close to 0.3. So anyway, we have an airflow of 664 CFMs. So that amount of CFMs is just too low. We need to have a CFM of around 800 CFMs because we have a model number outside that indicates 24,000 BTUs of heat removal. So for every 12,000 BTUs of heat removal, that's 1 ton of air conditioning, and you need roughly 400 CFMs for that. So since we have 24,000 BTUs, that's 2 tons, and we need around 800 CFMs. So this is just too low. So to increase the airflow, we either need to lower the static pressure to increase the airflow. In this case, we're going to need to jump to the medium blower speed, and then we're going to need to check our static pressure again on the return and the supply and line it up here with our airflow data. It's likely going to increase to maybe 0.4 or something like that. And then what's going to happen is we're going to have the correct amount of airflow. We're going to have just a little bit too much airflow. But if we would get right around 350 to 425 CFMs, that would be correct for every ton of airflow. So maybe we get 0.43, then we would be a little bit lower. We would be a little closer to what we need. So once again, you could, if there's a airflow restriction or maybe the filter is creating too much pressure drop across it, you might want to replace that with another one. But that's how you do it. That's how you check airflow and you set airflow with the manufacturer's data. So I have the air handler running in low speed still, and I just wanted to double check my measurements for my airflow with my hot wire anemometer. So my measurements here, I got an average CFM of 682. So that's very, very close to what we got when we took the total external static pressure of the air handler and compared that to the manufacturer's literature. If you want to learn more about airflow and checking the refrigerant charge and doing procedures to prepare a system for refrigerant, check out our book, The Refrigerant Charging and Service Procedures for Air Conditioning. We also have a 1,000-question workbook that you can do as a self-study guide with the answer key. We also have quick reference cards for out in the field for checking the charge and the total weight method and the pressure temperature charts and things like that. So hope you enjoyed yourself, and we'll see you next time at AEC Service Tech channel.